Okay, great. Thanks so much. Great talk, Karen. I enjoyed it. Now we're going to switch gears from Earth to Mars. We're going to talk about Perseverance and its little technology demonstration helicopter, which is Ingenuity. So what are the missions on Mars that we have? Well, today we have a whole series of orbiters. They come from many different countries. The European Space Agency working with Russia on Trace Gas Orbiter. The UAE has a mission. In addition to that, China has an orbiter and a landed system. But we also have the Indian Space Research Organization, in addition to the NASA missions, Mars Reconnaissance Orbiter and MAVEN, and then a NASA ESA mission called Mars Express, and then the NASA Mars Odyssey mission. These missions are critical for our landed assets because the data comes from those landed assets up to the orbiters and then are sent back to Earth. On the ground, the working systems, and there are quite a few of them now, include Curiosity, Insight, Perseverance, and of course Ingenuity, and then of course Zhulong, who is the new addition from China. It has a landed system and a rover. Now, in addition to that, how do these big missions get on the ground? Let me tell you that Curiosity and Perseverance are big. They're 1-ton rovers. Just as a scale, this is one of its wheels. So it's the size of an SUV, all right? And so it goes through quite a process. To land on Mars with a really thin atmosphere, it's about 1% of the Earth's atmosphere, about 6 or 7 millibar. It goes through 3 stages. Entry, which is the heat shield slowing it down. Descent, which is a parachute that continues to slow it down. And then a sky crane, jettison the parachute, and then drop the rover, okay? For which then a retro rockets fire, hover, and then land the rover, just like helicopters do, raising and lowering supplies to the surface all the time, every day here on Earth. So when the capsule with the rover in it hits the top of the atmosphere, it's going 7.8 kilometers per second, and when that rover touches down on the surface, it has to go centimeters per second. And it does all this in 7 minutes, okay? Now, let me show you a couple images from the entry, descent, and landing. Here is an actual image taken by the Mars Reconnaissance Orbiter. So as it was flying over near the area, it turned to the side and took a picture of Perseverance in its capsule right here. And you can see the parachute and the capsule blown up in this image on its way down to its landing site at Jezero Crater. And here it is. Here's the landing site. Okay? That's where it ends up. Now, the reason why Jezero Crater is so important is you can see it right here. We have a delta. This is a huge delta. There's a river that comes in that's dropped material into this crater. The delta is built up over tens of millions, perhaps several 100 million years, and the thickness of the delta is about 70 meters, all right? And so we landed in the crater itself, and we're going to start our way up, indeed, this delta, and we're going to take samples, because the key thing that Perseverance does is to be able to core rock, and we're going to bring those rocks back. This is the final stage of the descent. It's done with the sky crane, and here's the sky crane. You can't see it. It's taking a picture downward, and it's landing the rover, okay? And as it does that, the rover is all tucked up in the capsule, and it unfurls. So you can see the legs have just unfurled, and the wheels are starting to lock into place, all right? That's all happening while we're lowering it to the ground 30 meters up. So it's a little higher than this ceiling as it's coming down, all right? And then it sits down on the surface perfectly, and then the mast comes up, and we go through our checkouts. And of course, before we do that, we cut those lines, and the sky crane flies away and is destroyed by crashing somewhere else far away. That's what we want. We don't want it near it. Now here's the landing site, and we've named it Octavia E. Butler. She's a fabulous science fiction writer. This is in class, the same class with what we've been doing. Where Curiosity landed, we call that Ray Bradbury landing, all right? So one of the things that we've been doing. And of course, here's the first view, or one of the early views that they had of it sitting on the surface. Well, what is Perseverance all about? It's all about taking samples. And here's the samples. This is gives you an idea of the size. It's about the size of a chalkboard chalk. And looking over the crowd, there may be some in the crowd that have never used a chalkboard chalk, so I will just say a large Crayola crayon. All right, so, and we sleeve it in a tube. That tube is made of titanium, and then we hold on to them for a while after we make 4 or 5 of them, and then we're going to drop them in a location for later pickup. We're going to bring these samples back. Now, right now, we've taken 5 samples. 4 rock samples and 1 atmospheric sample, okay? And it's now going to turn its attention to start going up into the sediments that are this ancient delta. Now, of course, ancient deltas here, you know, we're really close to a fabulous delta. If you just drain the Gulf of Mexico, you'd see the delta that's here, and it's very similar to what's on Mars in Jezero crater, of course. The rest of these instruments do a variety of context measurements, high-resolution cameras. We do a lot of work in determining mineralogy. We get all kinds of observations and data. We have several lasers that actually burn little holes in rocks, and we watch that glow, and then we can determine what the elemental composition of, and then the mineralogy. And so consequently, many of those do that. We have a weather station, which is real important, because we also have, with this rover, a fabulous little helicopter. So the bottom line for Perseverance is that it's an astrobiology mission. It's going to look at that context with those context instruments, make decisions that, hey, this looks like potentially an area where ancient life could have been, because Mars was a blue planet 3 billion years ago, just like the Earth. When life started on Earth, Mars was a blue planet with plenty of water, a large ocean, and in this area, a river valley creating this delta. And then, of course, we get the geology of the context, we create samples, and then we bring them back. We also have some human exploration instruments, one of which that takes in the atmosphere, which is largely CO2, zaps it, pops off an oxygen, which combines with another oxygen, and we end up with carbon monoxide and molecular oxygen. And of course, what we want to do with the molecular oxygen is breathe it or create rocket fuel. And that instrument is called MOXIE, and it's working perfectly, very much like it does in the laboratory. So now we know we can scale it up and actually fly it with human exploration. What about the helicopter? This was a technology demonstration mission. We call this helicopter Ingenuity, named by kids in this country, just like Curiosity, just like Perseverance, just like Spirit and Opportunity before them. We like the naming contests when we do that. But this helicopter is really very simple. It's counter-rotating blades that are about 1 meter in size, okay? We don't have a tail rotor. We don't need it when you do counter-rotating blades. It has a couple sensors, an altitude sensor, but also 2 cameras, one looking forward, one looking down, okay? And it has the fastest processor we've ever launched into space. In fact, if I added up the processing speed of all the processors on all planetary missions and compared that to the speed of this processor, it pales in comparison. This processor is off the shelf. And so this is indeed a technology demonstration. We would not have launched this assuming that it was going to last long and work forever, okay, like we like all our missions to do. Won't happen. So, but we didn't know we could fly on Mars either. It's 4 pounds, and that's it. So how did we get it to the surface? Well, We got it to the surface because it sat underneath the belly pan of Perseverance, okay? It sat in this container. We dropped the container, and then we partially deployed it, 2 legs, then the other 2 legs. Then we dropped the helicopter on the surface, and we drove away, all right? And then it was ready to fly. And so indeed, when we gave it the okay, let's see you fly, it did. It did absolutely fantastic. Here's actually data from the altimeter, and you can see this perfect delta function. It just went right up, hovered, and it's over 3 meters above the surface, all right? It hovered and then came down. Worked perfectly. Now what we decided is, well, we need much more extensive flights. In fact, we had developed 5 flights. Now this is supposed to be a movie. Oh, there it is. Good. So here it is. This is the 3rd flight. This is an L. So we maneuvered it, and then we brought it back and sat it down exactly where it left. That was the 3rd test. And indeed, it worked perfectly. Worked absolutely perfectly. So we had to find 5 major flights. These were the test flights. And as you can see, we had certain heights, you know, where the maximum height that we have done actually is 10 meters. Not 5, as I mistakenly did that. The distance, the maximum height, the maximum distance is 215, and the maximum time is now 140 seconds. So those 5 flights worked perfectly, and now the copter was available to use. And the Perseverance team decided, hey, we could really use this by indeed taking a look at areas where we may consider to have the rover go, or where areas we never go, but we want the information. And in fact, this outcrop of rocks, we really wanted to see what it looked like. And here it is in its flight. It actually comes to these waypoints and turns. You can watch it turn. The whole image then just flips around, and off it goes. This is looking at the downward camera, all right? And so we bring in these high-resolution images from the helicopter, and then set it down in a place that we felt was very safe. It was the new landing site for it, and this was the 10th flight. You know, it's really pretty amazing that this technology works as well as it does. And then, of course, we land it right where we want. So pretty fantastic technology demonstration, and now we've pressed it into service. It has gone through 16 major flights and is still very operational and working well. And it's doing a variety of things in reconnaissance. It performs some really difficult maneuvers. It's exceeding all expectations. Well, what about the future? What do we plan to do with this copter in the future? Now that we know we can fly in the atmosphere of Mars, can we supersize it, okay? And it turns out our current estimates are, instead of a 4-pound helicopter, we might be able to increase it to 40 pounds, a factor of 10, all right? Now with that, you have much more capability to add a whole variety of instruments. Not only just imaging, but temperature and pressure measurements, humidity measurements, perhaps even some astrobiology sensors that could be deployed. One of the major places we would like to go to are lava caves on the surface of Mars. We believe there, and we've found several of them where the roofs have collapsed, all right, and you can look right in it. We know there are lava tubes. They're in and around the lava fields where there are some extensive volcanoes. This might be a great place for humans to be able to hunker down as they go and be able to egress and ingress and work in and around the area, so it's a potential landing site for humans. The reason why we like this is it provides protection from radiation. But in addition to that, we believe the temperature inside the lava tubes may be about the same during the day and during the night. Now think about that. On the surface of Mars, the temperature changes by 170 degrees Fahrenheit a day. All right? And if you had a structure on the surface, you have to be able to develop the capability to manage that temperature variation. But indeed, if we could go into a lava tube or a cave, we might be able to mitigate that and have systems that we actually can manage in the future. Well, this idea has really been picked up science fiction-wise. Here we see the National Geographic Mars series. And what they did is they came up with the concept of how to use the helicopters. This was in the third episode, where indeed they deployed a whole series of these. This was even done before we launched Perseverance, okay? They got really enamored with the idea of the helicopters, and indeed they pressed them into service in the science fiction series called Mars. And they did a spectacular job. They're out making measurements, taking surveys, and looking in an area actually for lava tubes is what they did. Now, in addition to pressing it into service for human exploration, there's huge vistas on Mars, and this, of course, is Valles Marineris, where we're going to go over a hill and then go over this huge valley. Valles Marineris is absolutely enormous. It's a canyon, sort of like the Grand Canyon, but then not like the Grand Canyon, because if you put that canyon here on the Earth, it would stretch from the Pacific Ocean to the Atlantic Ocean. And only one of the little tributaries is the size of our Grand Canyon. And so consequently, being able to move up and down these canyons and view a variety of different structures and even perhaps seeing if there is weeping going on crater walls, which actually may be occurring, and continuing on doing additional science, even with methane sniffers, if we can actually tease out if the aquifers, the underground aquifers, if they exist, actually have or maintain microbial life, the remaining microbial life that may be on Mars today, extant life today. So let me end by mentioning one other thing. We produced a book that's 50 years of solar system exploration. I brought 300 copies of this. I'll be signing them right here. If you'd like your free book, please come from 12:45 to 1:45 tomorrow and on Wednesday. We'll get them all signed out, and if you want a copy, please come early. Thank you very much.